Good morning students. Today we shall continue with our additive manufacturing. We shall start today with module 5 which deals with CNC technology and overview. Let us now discuss its introduction part. What are numerical control machines? Numerical control machines are also known as NC machines popularly, and these are used for the operation of machine tools. Numerical control is defined as a form of programmable automation in which the process is controlled by numbers, letters and symbols. So numerically controlled, as the term indicates, it is the one which makes use of numbers, letters and symbols. So which uses the programmable automation method to control the working of a machine tool. Numerical control machine is controlled by using a set of instructions. These set of instructions together form a program. So a program is major requirement for a numerical control machine. In these machines, the numbers form the basic program instructions for the different types of jobs. Hence, the name numerical control is given to this type of programming. Since it makes use of numbers, the numerical control machine is named as numerically controlled machine. When the type of job changes, the programming instructions also need to be changes according to the type of the job. It is very easy to write instructions for each job and allows the programmer lots of flexibility in its use, and that's why numerical control machines are most widely used. Then where do we find the application of this type of machines? NC machines or NC technology are used in various applications like drafting, assembly, inspection, sheet metal working, etc. Majorly, these are used for machining processes like turning, drilling, milling and shaping, etc. So, various applications where we find NC technology are drafting, assembly, inspection, sheet metal working. Apart from this, they are majorly used in turning, drilling, milling, shaping, etc. Due to numerical control, the machining operations can be performed at a faster rate, which helps in preparing bulk manufacturing at a very cheaper rate. So this is about the introduction of a numerical control machine. So numerical control machines are also called as NC machines, which makes use of numbers, letters and symbols, and these numbers, letters and symbols contribute to form a program together, and this program will help to carry out the work or the job at a faster rate and hence suitable for bulk manufacturing only. Let us now discuss the brief history about numerical control machines. Numerical control machines were invented in the year 1940 by a person called as Parsons. He invented these numerical control machines, and in these machines he made the use of punched cards. So punched cards were used to contain the data regarding the operation of the machine. So punched cards were used which contained the coordinate position to control this machine tool. So the machine was directed in small increments and the job was finished to the desired accuracy. In these machines, Parsons made the effort to introduce commercial numerical control units with automatically programmed tools, which is also known as apt language, and he used this apt language for programming the NC machines. Then what is this apt language? Apt language is the one which makes use of English-like statements, wherein the programmer can easily communicate with the machine instructions and the machine tools in a easier manner. This is one of the very widely used language in the manufacturing industry, and a number of modern programming languages are also based on this apt language. So how these numerical control machines were invented means the earlier ages punched cards were used. Later, using this punched cards, he could able to run a coordinate position system to control a machine tool. Later, he invented the use of automatically programmed tool, nothing but as a apt language. This apt language makes use of English-like statements. With the help of this apt language, the programmer could write the programs in a English manner, which is very easy for the programmer to communicate with as a machining instructions to the machining tools. With this NC machines, the development of CNC machines were involved. So that is the advent of CNC machines. How did the CNC machines took birth? In the initial years, where in numerical control machines, where they used punched tapes for feeding the instructions to the machine through a control unit, the apt language also marked the arrival of computer numerical controlled machines, which are also known as CNC machines. So these NC machines, which makes use of apt language, made use of computer numerical controlled machines, which are also known as CNC machines. This CNC machine program are fed to the computer to control the operations of the machine. The control unit is used to read the punched cards wherein the instructions are punched in the NC machines, and this was replaced in the CNC machines by a microcomputer. So a microcomputer replaced the punched cards, and that is what a CNC machine was. Later, the CNC machines overruled the NC machines, and they brought a major revolution in the manufacturing industry. Later, with the development, the CNC machine had a combination of computer-aided manufacturing and computer-aided designing, which is also known as CAD/CAM technology. So with the help of CAD/CAM technology, there were much developments in the CNC machines. So therefore, CNC machines rely on a system of 3 linear and 3 rotational axes. So machines such as CNC machines make use of 3 linear axes and 3 rotational axes in order to calculate the motion and position of machine components and workpieces. So therefore, a machine control unit will control and guide the movement of the machine tool in all these axes. What is CNC machining? Let us now discuss what is CNC machining. So CNC machining is known as a subtractive manufacturing technology. Why it is called as subtractive manufacturing technology? Because in case of CNC machining, a solid block is taken and various cutting tools are used to produce a part based on the CAD model prepared, and here, since the material is removed from the solid block to produce the part, it is called as subtractive manufacturing technology. CNC machining is capable of producing parts both from metals as well as plastics. Then what is the advantage of this major advantage of CNC machining? CNC machining can produce parts with tight tolerances and excellent material properties. That is, parts produced by CNC machining technology will be having closer tolerances and have excellent material properties. Let us now discuss what is meant by direct numerical control machines. Direct numerical control machines are also known as DNC. So DNC is a manufacturing system in which a number of machines are controlled by computer through direct connection and in real time. What is a DNC? A DNC is it is a manufacturing system in which a number of machines are there, and these machines are controlled by a computer through direct connection and in real time. DNC machines involves data connection and processing from the machine tool and back to the computer. So there is a change of information from the machine tool and to the computer. Direct numerical control is a process that is set in manufacturing unit where a set of machines are controlled by a programmed computer with the help of direct connection to the same. It is also known as distributed numerical control. So direct numerical control machines are also known as distributed numerical control machines. Direct numerical control machines are based on real-time data and involves the collection of data from machines and passing them to the mainframe at regular intervals. So in such cases, the operator will be in control of the mainframe computer through remote access. So in such case of machines, the operator will be capable of controlling the mainframe computer through remote accesses, and here it is a real-time data collection. Let us now see how the NC machines are classified. So NC machines or CNC machine tools are classified based on the type of motion. So the first classification is according to the type of motion. The first type of motion is point-to-point system. CNC machines or CNC machine tools make use of point-to-point systems. This is a type of system wherein the workpiece and the tool are placed in position and the tool will be doing its work. In these type of machines, the tool will be moving from point to point. Examples of point-to-point systems are drilling, tapping and boring machines. So the workpiece will not be moving, it will be stationary, and the tool will be moving from one point to another point until the tool will finish the job, and after the completion of the job, it will retract back to its original position for the safety purpose. The second type of classification is known as contouring system or continuous path. So how we discussed a point to point, okay, contrast to the point to point we have continuous path system. This type of machine tool works in a continuous path. That means the tool will be moving continuously by cutting the material and will follow a contour of the part. So whatever contour is programmed, according to that contour the tool will be moving. These machine tools are known as also contouring machines, and some of the operations which involve contouring machines are milling, lathe and routing machines. So these machines are capable of doing the work similar to say as the point-to-point system, but these machines require simultaneous movement of the tool and the work. That is, the position of the workpiece and the tool are simultaneously controlled by a control motion. As we discussed just now, a point-to-point system is one wherein the tool will be moving from one point to another point, and in contouring system the tool and the work are moving completely or simultaneously, so that the operations such as milling or lathe and routing machines will be using such a type of systems. Second classification of CNC machine tools is according to the type of looping system. Based on the looping system, they are classified as closed loop system and open loop system. In case of closed loop system, there is a feedback from the control system to the actual and the programmed input, and hence it is called as closed loop system. A feedback element will be there which will try to close the loop, and the major work of this feedback system in a control system is to provide the signals back to the actual system and the programmed input. So the CNC system works on servo mechanism operation. So the CNC machine which make use of closed loop system will work on servo mechanism. The feedback will be measured by analog or digital systems. So what is the purpose of analog system? The analog system will try to measure the physical variables such as position, velocity in terms of voltage levels, and the digital systems will try to monitor the electrical pulses. Such type of closed loop systems are very accurate and powerful, and hence they are having capability of monitoring the operational condition with the help of feedback systems, and that's why they are able to automatically adjust whatever the variations that occur during the machining systems in the real time only. Next, we shall discuss what is a open loop system. Here the feedback element is absent, and that's why the loop is not a closed one, hence it is known as a open loop system. In open loop system, the system is the one wherein the instructions of the program are sent into the controller through the input device, and then these instructions are converted to the signals by the controller and then sent to the servo amplifiers and to energize the servo motors. The open loop systems are usually used in point-to-point control systems, and in few of the continuous path control systems also we find the usage of open loop system. Here the drawback of this type of system is that the accuracy is less. So wherein we need not want the parts to be produced to much accuracy, then such type of systems can be used. So the major drawback of open loop system is that the accuracy will be lacking, and because of the absence of the feedback element, there is a chance of deviating from the actual position of the job or the actual type of the job required. So the result may be violated. The third type of classification is according to the number of axes. We commonly know that the movement of the tool or the workpiece can be done in two major directions, that is X and Y or X and Z. Based on this, the other type of classifications are done and they are discussed here. The first type is two-axis control system. In two-axis control system, the machine will give access to only two axes, that is X and Z axis. The best example is a lathe machine, wherein the machine is driven with the help of a servo motor, and that is a very good example of this two-axis control system. The second type is known as 2.5 axis control system, or it is also known as 2.5 axis machine. Apart from the two axes that we discussed, there is one more axis or another half axis, that is why it is also known as a three-dimensional movement. The best example for 2.5 axis control system is a drilling operation or a drilling machine and a tapping machine. In case of drilling machine or tapping machine, the feed or the machining mode will be there. During this feed mode or machining mode, the work will be done with the two-dimensional movements, that is X and Y, simultaneously along with the feed movement. That's why it is known as 2.5 axis machine or 2.5 axis machine. The third classification is 3-axis control machine. 3-axis control machine are the one wherein the machines are capable of moving in 3-dimensional, that is X, Y and Z axis simultaneously. These machines are most popular machines and they are capable of producing parts at higher accuracy, higher precision, and these type of machines make use of servo control mechanism, and this servo motor control helps for the movement of the tool as per the given instructions. So 3-axis control systems are limited for only simple jobs and for straightforward 3-axis jobs. The fourth classification among this one is a 4-axis control system. In 4-axis control system, as we discussed, along with the 3-axis machine, another extra rotation will be given. The rotation movement is known as B-axis. It is known as B-axis. So, including the generally 3-axis, one more rotation will be there, that is a B-axis. So, a 4-axis can be either a vertical machine or a horizontal type of machine. Then, where do we use such type of vertical CNC machines or horizontal 4-axis CNC machine? In a vertical 4-axis control system, the rotary head is added on the side of the machine bed. The machine will work as a 3-axis machine, but because of the rotary head, if we are supposed to drill the holes in a tube, then the tube can be mounted on that rotary B-axis and the drilling can be done at any required angle. So therefore, apart from the 3 normal movements, the rotary movement or the rotary B-axis will help for the drilling of the holes in any required angle. But these vertical 4-axis control systems are limited for small jobs only. Horizontal 4-axis machines are used worldwide for successful machining of big parts. In such machines, the machining can be completed in a single setup, or it may take 2 to 3 sets, or these machines are the one which makes use of 3-axis along with a B-axis. So therefore, the part is mounted on the bed, or the workpiece will be mounted on the bed, which will be having a 360-degree rotation around the Y direction, and hence it will help for giving a chance for the tool to cut on any angled faces in a single setup. So 4-axis control machines are of 2 types: vertical CNC machines or horizontal 4-axis machines. The last type of control system is 5-axis control system. 5-axis control system makes use of generally 3-axis, that is X, Y and Z, and along with that we have 2 rotary extra rotation, that is the rotations will be along Y and Z directions, and they are called as B-axis and A-axis. As in a 4-axis machine, B rotation is given by the bed and the A-axis rotation is given by the spindle movement, which is also called as pivot point. So here the 5 different axes are X, Y, Z and B axis and A axis. So totally altogether we have 5 axes. This B axis will be along Y direction and A axis will be along Z direction. So using this 5 axis machine will reduce the cycle time. So the time taken to produce any part will be reduced. So therefore it reduces the cycle time by machining the complex parts in a single setup, and therefore it will produce the parts with greater accuracy, and the eliminating such as the setup times or the errors will be eliminated by the use of 5 axis control systems. Let us now discuss the advantages of CNC machine tools. Few of the advantages of CNC machine tools are improved automation. So as we discussed, CNC machines make use of programs and the working will be at a faster rate, and hence the operator intervention during manufacturing will be reduced. So we can say almost it is eliminated. So there is no need of the operator to take part in the process of manufacturing. So that's why the CNC machines can run unattended during the entire machining cycle, thereby helping the operator to be free and help him to do such other type of tasks. So therefore completely CNC machines are automated, and hence there is a improved automation. The second advantage of CNC machines are accuracy. As we discussed, the parts produced by CNC machines are accurate and precise, and therefore the produced parts from CNC machines will be able to meet the specific dimensions and tolerances. The third advantage is repeatability and reliability. CNC machines will operate by means of programs that are loaded onto the machine. Once the program is verified and executed by the programmer, the same program can be recalled any number of times for the subsequent productions. So therefore this helps for maintaining the uniformity in the dimensions and the tolerances of the parts that are produced, and hence we can say that CNC machines are the one which can be used repeatedly, and we can produce the parts that are uniform or they are highly reliable. The fourth advantage of CNC machine is that flexibility. CNC machines can run a variety of programs, and they have workpieces leading to fast changeovers and setups. So programs can be modified as and when required before starting the machine operation, and hence CNC machine provides the flexibility of changing the program before the machine is switched on. Some other advantages are motion control. So CNC machines allow the motion of the cutting tool in 2 or more directions, and the machine slide, spindle and other parts are precisely controlled by means of servo motors instead of cams, levers as in conventional machines. The next advantage is reduced scrap and rework. Since the programs are fed, they are checked and fed, so therefore there is no scrap produced and there is no rework involved in such type of machines. CNC machines require lesser space, that is reduced space requirements. Since it can be used for parts with high dimensional accuracy and That's why these machines will try to reduce the inspection time as the produced parts are at higher accuracy. Reduced lead time. The time taken to produce a product is less, and hence the time such as lead time will be reduced. The CNC machines can run continuously for 24 hours and 365 days, and hence we can say that the machine can be utilized fully. So it is increased machine utilization. Coming to disadvantages of CNC machine tools. The major disadvantage of these type of machines is that the high initial cost of the machine. That is, these machines are costly. These machines require maintenance cost. That is, the maintenance cost of these machines is more. These machines require skilled programmer, and the operator, if he programs the program in an incorrect manner, then it will lead to misalignment of workpiece, and the locating the parts may be improperly done, and hence will lead to improper production. Let us now discuss some of the applications of CNC machine tools. CNC machine tools are used in a variety of industries. Commonly used are CNC drilling machine, CNC lathe, CNC machinings, which are also called as CNC milling centers. CNCs are also employed for CNC turret press and punching machine. Computer numerical control or CNC are also used for wire cut electrical discharge machines. We have CNC grinding machines and CNC laser cutting machine. CNC machine tools are also used for various operations such as industrial robots, shearing, flame or plasma cutting, punching, laser cutting, forming and welding, and many other applications. In the today's class, we have discussed the advantages, disadvantages and applications of CNC machine tools, the classifications of CNC machine tools, what is meant by NC machine tools, DNC machine tools and CNC machine tools. In the next class, we shall discuss some other topics on this chapter. So with this, we will try to complete our today's class. Thank you.